Ever since our grade 10 chemistry students learn that transition metals, or that there are some elements on the periodic table that can have multiple valences, the question always becomes why? And now that we're finally in grade 12 chemistry, I can start to give you an explanation. So that is what I'm going to do in this video, so let's get started. So we're going to look at iron as an example. Now iron, if you check on any periodic table, you can see it can have valences of 2 plus and 3 plus. So why? We're going to use our energy level diagram to figure that out. So let's start with just iron having 26 protons and neutral iron 26 electrons. We'll place 2 electrons in the 1s, 2 here, so that's a total of 4, and then 6 here. So now we have 10, and then 12, and now we have 18, and then 20, and finally 26. All right, so let's figure this out. Now the first step to determine an ion, or when it's going to be stable, is to look at the highest energy level or shell. And that's not going to be 3, that's going to be 4. Even though I realize there is an overlap in these orbitals, 4 is a higher shell. So we're going to remove these 2 outer electrons, forming a fairly stable iron 2 plus ion. Now this is fairly similar to in grade 10 when we do Bohr-Rutherford diagrams, right? So take lithium. If you took lithium, which has, we do the Bohr-Rutherford diagram, we remove the outer electron so that there is no more electrons in that outer shell, and we say it's stable. That's essentially what we're doing here. But we can go one step further. If we supply a little bit more energy, we can get rid of this electron, because it can be very stable if the next level down, our 3d orbital, is a half-filled shell. And half-filled shell, just like a full shell, can be a very, very stable atom. And so, getting rid of one more electron provides us with a second stable option, or a second stable ion for iron. And we can see this in other elements as well once we understand electron configuration, as opposed to previously in grade 10 when we did Bohr-Rutherford diagrams. I hope that helps quench your curiosity a little bit. If you have any questions, let me know. And if you're taking grade 12 physics, for now you can download in the description for free my course pack. And as always, thanks for watching.